In this video, we're going to talk about Unit 4, Objective 4, Absolute Extrema. Absolute Extrema differ from relative extrema in the sense that they are the highest or lowest point on the entire graph, as opposed to just in its region. These are also sometimes referred to as global extrema. So the difference would be if we have something like just a parabola here. We know that this point down at the bottom of our parabola, right there, our vertex, is the lowest point on my graph. Absolutely the lowest point. So this would be our absolute minimum. Now, this is also going to be a relative min as well, because it does fall lower than everything in its little area, its neighborhood there. So it's also a relative min. So this is kind of like all squares are rectangles, but not all rectangles are squares. All absolute extreme values are also relative extreme values, but not the other way around. So where we're going to see these most of the time on your AP exam is going to be when you have a closed interval. So the two ways that you'll see that is you'll see it either with brackets, the interval from A to B, or they'll say A is less than or equal to X is less than or equal to B. So something that tells us we can actually be those endpoints on our interval, that's going to be the giveaway that we need to be using our global or absolute extreme values. So the process is not going to change at all, at the beginning anyway. So what we're going to want to do is we're going to find our critical points, which are when f prime of x equals 0 or does not exist. So don't forget the does not exist part. We want to do our number line to find our relative max and mins. And then the new part is going to be number 3. We want to test all y values of endpoints and relative extrema. So when they're asking for the absolute max or min, they're generally going to be wanting the y value. When they're asking for the relative max or min, they're generally going to ask where does the relative max or min happen. So we'll be able to stop with just the x values. But the important part on number 3 is not just testing your y values, but testing the y values of your endpoints as well as your relative extrema. So let's look at a relatively easy example. Let's just say find the global or the absolute, so let's say absolute minimum of y equals, let's say 2x squared plus 4x on the interval -2 to 4. So we want to take the same process. We know we're trying to find a minimum, so we're looking for when f prime of x is going to change from some negative value, some negative value to a positive value. So we need to find when our first derivative is 0 or our first derivative is undefined. So let's find our first derivative. Be 4x plus 4. So that's never going to be undefined. So never undefined. So we just need to worry about when this thing is equal to 0. I'm going to go ahead and factor out a 4. So that equals 0 when x equals -1. So if we take a number less than -1, say -2, plug it into our derivative, we're going to get a negative number. If we take a number bigger than -1, say 0, we'll get a positive number. So if we think about our number line, we know that x equals -1 is a relative min. And that's because our derivative changed from negative to positive. So we now have to test 3 points to figure out what our absolute minimum is. So we need to make a little chart over here to figure out what our absolute minimum is. We need to check -2, we need to check -1, and we need to check 4. Now, where we're possibly going to make our mistakes is we're going to try to plug these back into our derivative when we don't want to. Where we want to look is back at our problem up here. So we want the absolute minimum of this function, so we want to find out what the smallest value of that function is. So we want to plug these values into the function. So -2 squared is 4 times 2 is 8 minus 8 from the other ones, that should give us a 0. -1 squared is 1 times 2 is 2 minus 4 is -2, and 4 squared is 16. 32 and 16 is what, 48? So all we have to do now is look at our table and try to find what the smallest value is. So the smallest value, our absolute minimum, is -1, -2. And we know that because the only relative max and mins that we had were at -1, and then the other places are minimums or maximums can happen where the endpoint. So there's nothing other than those 3 possibilities for an absolute minimum or absolute maximum. So we pick the smallest value because we're trying to find the minimum. Now, if our number line had turned out to look like this, we would not have to check -1 in our table. Because the problem's asking for a minimum, and we can see from our table down here that this would be a relative max. A relative maximum is never going to be the absolute minimum, so we wouldn't have to put it into our table. But since it did turn out to give us a relative minimum, we did need to check it, and it actually turned out to be our absolute maximum. So that's going to do it for this video. We'll see you in the next one.